Ever wondered what the reduce function in Python actually does? Let's solve a HackerRank problem and make it super crystal clear. But I'm gonna quickly ask you for a favor. The last time we checked the statistics of our channel, only 86% of the people who watch our channel have actually subscribed. My goal is to get to 50%. If you have ever liked our videos and liked the content that we post, I'm gonna ask you for a very small favor to hit that subscribe button. It helps the channel more than you know, and as the channel gets bigger and we have more audience, it really encourages us to create more quality videos for you. Thank you and enjoy this episode. As you know me, Amir here, nice to meet you. And today we are solving the reduce function. Like always, I will have HackerRank on the left-hand side of your screen, and I will have a Jupyter Notebook in black on the right-hand side. Let me show you. The reduce function is a very powerful function. It allows a lot of simplifications and faster operations in your code. Let's see what actually the task is here. So I'm just going to click on the task. Given a list of rational numbers, find their product. And this is quite important. But if you don't know what rational numbers are, any form of, for example, 3 over 2, 1 over 3, P over Q, and such is called a rational number. So I'm just going to get rid of this page for now. I know that I'll be getting a list of rational numbers, but let me quickly read through the concept. The reduce function applies a function of two arguments cumulatively on a list of objects in succession from left to right to reduce it to one value. I can show you a very quick example in my Jupyter Notebook. I've got a full video on reduce function. The link is up at the top right. But for now, I will only suffice to one small example. This example is exactly the one that you've got on the screen here. So maybe I will just copy this and paste it into my Jupyter Notebook, and I will run it, but it's not going to run because I haven't really imported the reduce function. So what I will do, I will say from func tools, if I press tab, import reduce. That's how I import the reduce function. And when I run this, you will see that the answer is 6. But let me really run you through what's going on. We have a list that has 1, 2, and 3 in it. What we are hoping is to add them together, 1 plus 2 plus 3, which makes it a 6. Now, the easy way would be to say, 1 plus 2 plus 3. Well, I'm not really looking for easy because this is not how AI works. This is not how programming works. We are looking for the most efficient and most future-proof solutions. Now, in the back end, if you want to understand what's happening, this x for the very first time will take 1 and y will take 2. So I have 1 and 2. What am I asking them to do? Well, I'm asking them to say 1 plus 2. Then 1 plus 2 equals 3. Now, these two equal 3, and now we have a new set, which is 3, the one that we just added, and the 3 that is already there. So what I'm going to do, I'm going to say, okay, this is 3 from adding 1 and 2, and this one is 3. So 3 plus 3 equals 6. And this is the power of two functions. One is lambda. I have a full video on lambda. And the next one is reduce. So you hopefully are getting the idea. Now, if I tried this with multiplication, not just addition, maybe if I want to multiply them, I would be getting the same thing because 1 times 2 is 2 and 2 times 3 is 6. If I decided I wanted to subtract, I will be -4 because 1 -2 is -1 and -1 -3 is -4. So hopefully this reduce function kind of makes sense for now. But let's see what the task is. Just going to scroll down to the input format. First line contains n, the number of rational numbers. Let me show you the example. If I scroll down, you will see that n here equals 3. So maybe I need to ask the user to give me n. Well, that's what I'm going to do. Let me just open a new step 1 here, step 1, which is n equals integer of what the user gives me. The user, for example, gives me 3, and if I print n, you should here see that n is 3. So we will get an n from the user. Let's see what actually n is. The number of rational numbers. So we will be receiving 3 rational numbers. The ith of the next n lines contain 2 integers. So we will have, for example, in this case, we will have 3 lines. Each of them will have 2 integers. Let me show it to you. Right here, you can see there is 1 and 2, there is 3 and 4, and there is 10 and 6. And now you can see that how I am breaking the problem into smaller bits. That's what I'm really hoping to do in this channel, help you break the problem into pieces and solve them piece by piece, put it together, make a solution. Okay, so we've got 2 integers, the numerator which sits up the top of a rational number, and the denominator which sits at the bottom. So for example, 1 over 2, numerator and denominator. Okay. Now, what is the output? What is it asking us? It says print only one line containing the numerator and denominator of what? Of the product of the numbers. So I have to say all the numerators have to be multiplied by each other, and all the denominators have to be multiplied. And then all I have to do is to give you the final numerator and the final denominator. Just remember that the numerator and denominator can be sometimes simplified. For example, 2 over 4 can be simplified to 1 over 2 because both of them can be divided by 2, which is called GCD. I'll show you in a second. But now, going back to the output format, we will be printing one line containing the numerator and denominator, the denominator of the product of the numbers in the list in its simplest form. So, for example, let me show you quickly here. If the final result is somehow 2 over 4, the question doesn't want us to give 2 and 4. The question says, hey, 2 over 4 can be simplified as 1 over 2. And I want you to give me 1 space 2. I don't want you to give me 2 space 4. So just make sure that we understand that. I will quickly introduce you the concept of GCD. That's exactly what I talked about. So if you import the math library, because you have to import math library, and from math you use GCD, which is greatest common divisor, and you look at the GCD of 2 and 4, you will see that 2 itself is the GCD of 2 and 4. What does it actually mean? It means between 2 and 4, what is the biggest number that you can find that you can easily divide both of these numbers with that third number without having a remainder? Well, between 2 and 4, I can divide both of them by 1, but is number 1 the biggest number I can select? No, because between 2 and 4, I can actually select 2, and I can divide both of them by 2 and have a happy life. Now, I will give you another example. So, what is the GCD between 20 and 45? Have a guess. What is the biggest number between these two bigger numbers that you can comfortably take and the division is happy days? I suspect that should be a 5, isn't it? Well, yes, the answer is 5 because you can divide 20 by 5 and that will be 4. And then you can divide 45 by 5, which will be 9. And this is what the question is asking us, not in really simple integer format, because what I'm showing you here is integer format. It's easy. We can think of it. We have to go back to rational numbers, find the product of numerators, find the product of denominators, and then look at GCD. Let me write those steps down. So step number 1 here was to take n, right? Now I will delete all these extra steps so that I can run you a bit more neatly through step 2, which is find the product of all entries, maybe. And then step 3 will be find the GCD of the final product. So this is what I'm going to do, and I'm going to run one by one through this. Looking at the sample input, I am taking n from the user. That's easy. I have already written it. I don't have any problem with that. I will take n. How do I take the next 3, the next 5, the next 10 lines so that I can take them in and think of them as fractions, 1 over 2, 3 over 4, and such and such? From here on, I am going to give you two solutions. Solution number one will be an easier one. You can just run with it. You can understand it right away. And also, I will give you a solution number two. It is a bit more advanced. It is a bit more thinking involved, but I will run you through the details of both solutions. Now, let's start with the easy solution. When the user tells me that they have three entries to work with, all I need to make sure is to accept the entries from the user. Well, if you look at how the user will give me those entries is 1 space 2. I will have to ask for a for loop that runs 3 times for the number of n times. And if I print I, and you will see that I will have 0 and 1 and 2. So that's easy. And every time I need to ask the user, hey, give me your numbers. Give me your next set of numbers. Give me the next set of numbers. So let me do that. Maybe I'll be getting n and m from the user for 3 times because that's what's happening here. I'll be getting 1 and 2, 3 and 4, 10 and 6. So let me do that. I'll ask the user, can you input those numbers? Well, those numbers are not going to come as numbers from the input function. If you haven't seen my video on the input function, the link is up the top right. But the essence of that video is that the input function gives you strings. I don't want strings. I will need to split them based on the space between them because it says 1 space 2. I will use that space to break them. Once I break them, I will need to convert them from a string to a number. How do I do that? Well, I'll have to use the map function. The link for the video on the map function is up the top right if you want to understand what it does. I will map the integer function on the actual output of the user input, all right? If I do this, let me see if I am running this correctly. So I will have 3 inputs, and it says, okay, 1 and 2, all right, 3 and 4, 10 and 6. Looks like it's working. Functionally, it is working. I'm not sure if it is doing the job yet, but it's functionally working. So now, I am taking the inputs from the user, and all I need to do now is to multiply the top bits, the numerators by each other, and the denominators by each other. So that also needs to happen inside the for loop because the user gives me 1 and 2, so I will have 1 over 2 times 3 over 4 times 10 over 6. I have to do it right now. But for that, how do I capture and multiply as I go? I know what to do. What I will do, I will create 2 new variables. I will call one of them the numerator and the other one the denominator. And both of them will be 1 and 1 because 1 times anything doesn't have any problem. 1 times 5 is still 5. It doesn't harm, but it helps me solve this problem. Every time, right, when the user gives me n, which is the numerator, or m, which is the denominator, I'll have to multiply it by the previous number, the numerator, or the denominator. That's what I'm going to do. Every time when you give me new input, for example, 1 over 2, I will multiply it by 1 over 1. Put it all together, keep it. When the user gives me 3 over 4, I will say, all right, 3 over 4 is new. What I had before was 1 over 2. Let's multiply them. That's how I'm going to do it. This is going to happen through this. So the numerator is going to be every time the previous numerator times the new numerator. I'm going to do the same thing for the denominator. So every time the denominator equals the previous denominator times the new denominator. If I want to write these 2 lines a bit sexy and a bit more fancy, this is how I will write it. I will get rid of these and I will write it like this. You might ask, hey, Amir, how did you do it? I will make a video for that. But for now, remember that it's not going to change. It's going to do exactly the same thing, but this is a bit more advanced way of writing this. I'm going to do the same for the denominator, right? So now, I think my step 2 has also happened. So let me just copy that and paste my step 2 here because I'm doing it. I'm going to run this and we're going to do it again. So 3 times 1 and 2, 3 and 4, 10 and 6. So if I show you, for example, numerator, you will see that the numerator equals 30 because 1 times 3 times 10 equals 30. If I show you den, you will see that den is 48 because 2 times 4 is 8 and 8 times 6 is 48. All right, so now I know what I'm doing. But step 3 for me is to find the GCD of the final product, the greatest common divisor. And that's pretty easy. For the greatest common divisor, I will create a new variable, maybe, and I'll call it G. And I will say math.gcd of the numerator and the denominator. If I print G, let's see what it will give me. It will give me 6. So what I have to do is to take 30 and 48, divide both of them by 6, and print the result. Literally, that's what I will do. I will say print numerator floor division by G. And I will do the same denominator floor division by G. Once I print that, you will see that their answer is 5 and 8. And what we were expecting here was 5 and 8 as well. So this is solution number 1, the easier solution. I will send this to Hackerrank, see if it is happy, and I will show you a bit more fancy and advanced way of writing it. Stay tuned for that one. But for now, just wait. But if I copy and paste this code into Hackerrank, it's not going to work because Hackerrank is expecting me to complete this line with a reduce statement. So if I do my best and bring that answers here, it might work, but I'm not going to really take that time. I'm just going to go to my second solution, which is going to keep Hackerrank really happy. For me to be able to show you the second solution, I need to do a bit of cleaning. So let me write down solution number 2. And I'll make it bold and nice. I'll come up here and I'll call this solution number 1. I'll make that one also here. All right, so starting in solution number 2, I still need to import the reduce function. So from functools, import reduce function, and also from fractions, import fraction. Okay, all right, now that I've imported the reduce and the fraction from the fractions, all I need to do is replicate how I read value n from the user. So that's very easy. This next one is a bit tricky, but this is the section that I will be getting multiple fractions from the user using the fraction concept. So if I call these fracs, because that's what Hackerrank is calling in the solution, I can show you that Hackerrank is asking for something called fracs within the function. I will use the same thing. So the fracs will use the fraction idea, but wait for now. I will do what I did before. So I will have to map the integer function to the input that the user gives me, and the input that the user gives me is a string. So first split that based on that space between the two numbers because it is 1 space 2. I will break them and I will convert each of them into an integer. This is what's happening here. And then I will have to use the concept of fractions. So if you don't know what a fraction is, you can find information about it in the Python docs. But for now, for this video, I'm not going to really focus on that. So once I have taken this as a fraction, so the user gives me a lot of different things, I convert them to fractions. And then all I have to also make sure is I am running a for loop because that's how I'm getting the user input, breaking them based on a space, converting them to different integers, and putting them in a fraction format, numerator, denominator. This is what's happening here. So if I close this, let me put all of that in a square bracket to make it nice and tidy. I'm missing a parentheses, one missing here. So I'll enter what exactly is on Hackerrank. So I have 3, 1 space 2, 3 space 4, and 10 space 6. That's all good. If I show you what fracs looks like, sorry, wrong dictation. Fracs is a fraction of 1 and 2, fraction of 3 and 4, fraction of 5 and 3, because it was 10 and 6, but it just makes it simple and says 10 and 6. If I divide both of them by 2, will be 10 over 6 equals 5 over 3. That's why you see 5 over 3, because I said 10 and 6, and it just said, no, it's 5 and 3. All right, that's okay. Now that I've got the fracs, I have to reduce them. Let me call a new parameter as result. I'll be using the reduce function, and I will have the lambda who takes x and y. It is just common sense. It is just a standard form. And every time you take x and y, all you need to do is to multiply them because that's what the question is asking me. And just make sure you run that on fracs. If I show you the result, you will see that the result is a fraction of 5 and 8. And that's the answer that I'm expecting to see here. I have to do a very small tweak here so that I will see 5 space 8, and it is already here, right? So that's what I want to see. If I go result numerator, right, I will see 5. And if I see result denominator, I will see 8. So all I have to do now is to print result numerator and result denominator, and I'll get 5 and 8. That's as easy as that. So there is only one line that I have to copy from here to Hackerrank, and I think that's this line. Let me just make sure if I agree with that. So complete this line with a reduce statement. Okay, I will just paste what I had there, and I will try and see if it works. All right, if I run the code, fingers crossed, this will be successful. Yep, first test case is successful. If I submit the code, all test cases were successful. So if you like this video and enjoyed how I explained things to you, hit the like button, share it with your friends, and help me grow our channel.